Hello, you are welcome to this class. My name is Dr. Kingsley. Okay, this is a continuation class, okay, on physical and chemical properties of alkenes, part 2. Okay, this class will help those who are preparing for exams such as the AP, GCSCE, okay, SAT exam, NECO, WAEC, UTME. So please do well to subscribe to my videos. Thank you. So the next reaction that we are going to take, reactions of what or properties of alkanes that we want to take next is ozonolysis. Okay, ozonolysis of alkanes. That is number 3. You know, the first one we took is what? Is combustion reaction, that is oxidation. Then number 2 is addition. And we have seen several things that can be added to what? To alkanes. So after that, we now come to what? The third, which is what? Ozonolysis. Ozonolysis, okay, of alkanes. What is ozonolysis of alkanes? Ozonolysis of alkanes is the addition of ozone, okay, to alkanes to give you an ozonide. So when we have alkane plus ozone, that this is ozone, it will give us what? Ozonide and ozonide. Okay, that is how it is. But alkene will react with ozone in the presence of CH3COOH. So in the presence of what? Of ethanoic acid. Ozone react with alkanes in the presence of what? Ethanoic acid to give us what? Ozone. We might use ethanoic acid, okay, here. We can equally use ethyl ethanoate. We can use ethyl ethanoate, okay. If we like, we can use okay, that is dichloromethane. If we like, we can use trichloromethane. If we like, we can use tetrachloromethane. Any of these, okay, any of these can go here. So we can use either, okay, ethanoic acid or ethyl ethanoate or dichloroethane or any of these. Now let us use an example of what? Alkane. One example of alkane to show the reaction of ozonolysis. Now what we have is CH3, CH3, double bond CH, then we have CH3. This is what? This is an alkane and is reacted with what? Ozone. So what we are going to get in this reaction, is what? Is okay, ozonide. Yes, we are going to get ozonide, but of course it will be in the presence of either of these that I've told you, CH3COOH, which is, I'm using ethanoic acid now. So when this reacts with this, we are getting ozonide. Okay, so let me know if I can squeeze this here. Okay, it's too small, so let us use this side. Okay, what will happen is we'll have an ozonide. You have CH3, okay, your what? CH. All right, this is your CH what? 3. Then here you have a CH, okay, CH what? 3. Remember, this is where the double bond is supposed to be, but in the formation of the ozonide, the double bond is broken because we are adding 3 hydrogen. 3 oxygen. One of the oxygen, okay, bond to this what? To this side, while the remaining 2 bond to this side. So we complete the structure. So this is a ozonide, okay, ozonide. So you see, this reacts with this to give you what? An ozonide. Now remember, how do you practice how to write an ozonide? Let me show you. If you have C, double bond C, and you are reacting it with what? O3, which is ozone. I hope you can see this place. which is ozone. Okay, if you are reacting this and this to get ozone, how will this ozone add to this what? Double bond. How is as is just put the two carbons, remove the double bond and put the what? Two carbons. Then take one oxygen up, bonded to these two carbons. Then remaining two oxygens, one will go down, the other will go down, then you link two of them. That is actually the skeleton of ozonide. So that is what we have here. So anytime we are reacting alkene with ozone in the presence of acetic acid, you are going to get an ozonide. Now, an ozonide can be broken down, okay, by zinc in acetic acid. An ozonide can be broken down by zinc in acetic acid to give us what? Carbonic compound. That is alkanal and alkanones. So look at what I mean by this. An alkene plus ozone, and what we got is what? Ozonide. Now this ozonide, we want to break it down. So we put what? Zinc in what? In acetic acid. That is zinc in ethanoic acid. That is what I mean. The IUPAC name, zinc in ethanoic acid. Now once this happens, this ozonide will do what? We break. The ozonide will decompose. Okay? To give us, what we have here is CH3. Remember, here is what? C. Okay? And the other one is what? CH3. This ozonide will oxidize this place so that you have what? You have CO. So you are having what here? You are having alkanone. Remember, when you have two carbon attached to another carbon, you must have alkanone, because alkanone we have what? We have the functional group, okay, between two carbons. So plus the next compound you get is this side. You write your what? CH3. I hope you can see. That is CH3. Okay. Then this is what? CH. This CH, okay, it just, the H here can be written here if we like. So we're having CH3. Okay, this C will also carry the oxide to double bond. Okay, but the hydrogen up here is still there. This is a hydrogen. So how I'll know that this one is a alkanal is that this is CH3. This C will carry double bond O, CO. Then the next one is hydrogen. So alkanals we have what? Hydrogen. How do I know that this one is a alkanone? CH3, this one will become what? Oxide to C double bond O. Then there is another CH3 covering it, the functional group. So that is why it must become what? It must become an alkanone. Now, having seen this, I want to clean the board and let us know that the composition of oxonide can be done with what? Several chemical reagents. You can decompose an ozonide by simply boiling the ozonide. You can decompose an ozonide by reacting it with what? Moist silver oxide, silver 1 oxide. You can decompose an ozonide using what? Lithium tetrahydride aluminate. The reagent you use to decompose an ozonide will determine the final compound that will be formed. Now the compound we use is CH3. You have CH, then CH3, okay, double bond. We have CH, CH, then CH what? 3. Okay, now this is CH, if we like. Okay, just the same thing. Now, how do we produce our ozonide? Our ozonide becomes CH3. Okay, I have my C. Okay, then CH3. Remove the double bond, remove it. Start with the other carbon. You have your H, then CH what? 3. Now, complete. Remember, plus what? Plus ozone. Plus ozone. We are adding ozone to this. So remove one hydrogen and put it between the two carbon up. then the other 2 hydrogen will be down. This is the what? The ozonide. Now we want to decompose this ozonide using different what? Reagents. Now the first reagent I want to use is just boiling. I don't want to use any reagent. I just want to boil with water. So I want to decompose with boiling water. So what we have is here is a CH3. Okay, CH3. Remember the CH what? 3 up. Then here is what? C hydrogen here. Okay, and here we are having O and what? And O. This is the what? The ozonide. Now I want to break this down, this ozonide, using what? Boiling water, H2O. That is, I boil. Anytime you decompose an ozonide by boiling, the ozonide will decompose into CH3. Okay, you have C, CH3, double bond O, plus, okay, CH, C double bond O, okay, then H, then CH3. Remember, this is what? This, and this is this. Then plus H2O2. So boiling an ozonide, we produce what? Hydrogen peroxide. And we know that hydrogen peroxide is an oxidizing agent. If hydrogen peroxide is an oxidizing agent, it cannot oxidize what? Alkanones, because alkanones are rarely oxidized. But this is an alkana. Alkanas are easily what? Oxidized. So this hydrogen peroxide will oxidize what? The alkana. So that what the final product that we will have will become the what? The alkanone. Okay, the alkanone, this. Then plus, instead of us having what? Alkanal, the alkanal will be oxidized to alkanoic acid, which is CH3, then COOH. I hope you can see the board here. Okay, so having seen this, we find out that what? That when we decompose an oxonide using boiling water, we are going to produce as the final product. We are going to get an alkanone and what? An alkanoic acid, and not what? Alkanal. Why? Because the alkanal will be what? Oxidized to this alkanoic acid. Now, if we use moist silver oxide, we also do the same thing as boiling water. So the composition of an ozonide using boiling water and moist silver oxide will give you what? An alkanone and what? An alkanoic acid. So that is the first thing we need to know. Then another reagent we can use to decompose an ozonide. We can use another reagent to decompose an ozonide. Okay, we can use LiAlH4 or NaBH4. We can use this to decompose an ozonide. What is this? Lithium tetrahydroaluminate, okay, or lithium aluminium tetrahydride. You can also use what? Sodium tetrahydroborate. Anytime you use any of these to decompose an ozonide, the final product will be what? Primary alkanol and secondary alkanol, depending on the starting reagent. Now, when we have an ozonide, which the one we produced before, we have what? We have this, okay? I mean the ozonide we had before. This is a CH3, then CH3. We have what? Here, CH and what? CH3. This is the ozonide that we what? That we produced earlier. Then if we want to break it down using LiAlH form, what will be formed is what? Primary alcohol and what? Secondary alcohol. This will give us what? Secondary alcohol. Why this will give us primary alcohol? How is this? We will get what? CH3, CH3, which is what? This. Then the hydrogen here is OH. Then plus the other side, we have what? CH3, okay? We have what? We have what? H. And the hydrogen here is CH2, okay? Let me write it this way, plus this plus. We'll be having CH3, okay, CH2OH. So this one will give us primary alkanol. While this side will give us what? Secondary alkanol. When the ozonide what? Breaks. So that is what? Ozonolysis of alkanes. Now, the final reactions of alkanes is polymerization. Polymerization of alkanes, okay, is a reaction of alkanes to give what? Polymers. So a polymer is a giant molecule that is made up of smaller molecules, which we call monomers. For example, ethene can become a monomer to form polyethene. When we combine ethenes, okay, n molecules of ethene, that is, it might be in hundreds or 1000s molecules of ethene, we combine together to give us a polymer that we call polyethene. Okay, so that is the last what? The last reaction of what? Of alkanes. So alkanes undergo combustion or oxidation. Alkanes undergoes what? Addition reaction. There are so many addition reactions that I gave you. Then number 3, alkanes can also undergo ozonolysis. And number 4, alkanes can undergo polymerization. I believe that we have learned a lot from this class. I always want you to subscribe to my class, okay? Subscribe, share the videos, like the videos, recommend them to as many that are preparing for A-level exam, O-level exam, such as WAEC, JAMB, okay, NAPTEB. It is also highly recommended for first year students. Thank you very much.